Okay students, today we will be discussing about a part of the organic chemistry. In the previous class we discussed about the IUPAC nomenclature, also about homologous series, different functional groups and so on. We practiced many of the nomenclatures as well. So in today's class we will be talking about alkanes. We discussed that the saturated hydrocarbons, means compounds which are made up of carbon and hydrogen, are actually called as the hydrocarbons. Of these, the compounds in which all the four valencies of each and every carbon is satisfied with a single bond is actually called as the hydrocarbon. Now let us understand what do you mean by this saturated hydrocarbon and what you call them. Saturated hydrocarbon means, suppose I am giving you an example of C2H6. If you are writing the structural formula of this compound, you will write it like this. So this is how it actually looks like. So if we see the structure of this compound, the concept that has to be clear. See, for this carbon also all the four valencies is satisfied with single bond. And even for this carbon, all the four valencies are satisfied with a single bond. And this is called saturation. What is saturation? Saturation means कि ये अभी भर चुका है. मतलब এর ওপর আমি আর কিছু অ্যাড করতে পারবো না. So the thing is, all the four bonds are already done. So carbon cannot have 5 bonds. This is the concept of saturation. Okay. If it was bonding with 3 different groups, then you could have removed one bond and added another element. That could have been done. But if 4 different bonds are done with 4 different atoms, then that is called saturation in case of a carbon atom. Now, alkanes are the compounds in which all the carbon atoms are satisfying all of their bonds with the help of single bonds. Now we discussed the smallest member of this alkane family is the CH4, which we also call as the methane. We also discussed about ethane, means it has 2 carbon atoms C2H6, 3 carbon atoms C3H8, that is propane, butane with 4 carbon atoms C4H10 and so on. The general formula of this alkane group was CnH2n plus 2. The general formula was CnH2n plus 2. Okay, so if carbon is 1, hydrogen will be 4. If carbon is 2, hydrogen will be 6. If carbon is 3, hydrogen will be 8. And so on, it will continue. Now let us understand the basic concept of this alkanes. Now when we are talking about alkanes, the basic thing is that these alkanes are saturated hydrocarbons. The concern that we will show today is about how these hydrocarbons or the alkanes can be prepared and what are the chemical properties of these alkanes. This will be our point of discussion today. So first let us understand how they can be prepared. To prepare this methane, what you have to take first is what you call as CH3COONA. Do you know what is the name of this compound? This compound is called sodium ethanoate. Let us see. Sodium ethanoate. We will discuss that. We will again discuss about the nomenclature. Okay. This group, if it is having COO, then it is called the alkyl alkanoate group. That is ester group. That we will discuss later on. So this is sodium ethanoate. Now to this, you have to add soda lime. Now what is soda lime? So when I am talking about soda lime means NaOH plus CaO. CaO is called quicklime. So NaOH, okay, plus this CaO is together called soda lime. And now sodium ethanoate plus if we are giving NaOH and we are hitting it in presence of this quicklime. So what is happening? What are the results that we are getting? We will show you how the compound is getting formed. See, this is the name of the compound. Okay, sodium ethanoate, that is what we were talking about. So the compound will be looking like this. This part will be forming one compound, that is Na2 CO3, sodium carbonate, plus this CH3 and H, this will form one, that is the CH4. So you will be getting two products. One is the methane, the second one is this sodium carbonate. Now try to understand. See, in the parent molecule, there was two carbon. Can you see there? There are two carbons. Okay. Sodium ethanoate, even the name indicates that there are two carbon. But in the compound which is formed, there is only one carbon. It is the methane. Okay. So there is only one carbon. So we have lost one carbon atom in the form of sodium carbonate. So if we are losing a carbon dioxide molecule, that is COO. Okay. If we are losing this carbon in the form of carbon dioxide or even in the form of carbonate, this is called decarboxylation. So this reaction is also known as decarboxylation reaction. Decarboxylation reaction. Is it clear? We are losing this carbon dioxide molecule, that is COO. So we are losing it. It is not actually molecule, but we are losing carbon and oxygen in a ratio of 2:1 from this molecule. This is in the form of carbonate. So this is called decarboxylation reaction. But the question is, this is how we prepare methane, and what we are learning is the preparation of any alkane. So how to do that? For doing that, what we have to consider is, see, to make one carbon containing hydrocarbon, that is methane, you require two carbon containing alkanoid. Okay. So to prepare two carbon containing this hydrocarbon, you require one more, means three carbon containing this. So that will be called as, so we are showing this reaction. I am showing you this reaction. See, for this you have to take C2H5, okay, COONA, C2H5, COONA. This is called sodium propanoid. This is called sodium propanoid. See, how many carbon are there? 3 carbon. So sodium propanoid plus again the same thing, that is NaOH, that is, and CaO will be here, and then you will get this as one part, NaO and CONA. This you will get as Na2CO3, and another part is C2H6 as the product. This is ethane. Okay. So if you are trying to form propane, for that you require what? Sodium butanoate. Okay. If you are trying to make butane, for that you require what? Sodium pentanoate and so on. Is it clear? This methane or ethane, whatever, suppose methane is formed. How it is collected? If methane is formed, how it is collected? It is collected by downward displacement of water. Now what is mean by downward displacement of water? You will place a flask of water or a glass of water, not glass of water, a flask containing water in a water trough. So what will happen? Gas will be moving. So what will be happening? This gas will moving in the form of bubbles to the upper part. Why? Because the gas is lighter than water and the gas is insoluble in water. Two conditions. It has to be lighter. Second is it has to be insoluble. These two conditions has to be satisfied. Then only this upward movement of or downward movement of water can be used for collecting the gas. Is it clear? The next thing that we will be discussing is that why soda lime is used instead of NaOH. This is NaOH. Okay. So why instead of, this is caustic soda. So instead of using caustic soda, why we are using soda lime? The reason is it is not deliquescent and it does not attack glass. There are two reasons. It is not deliquescent and it does not attack the glass. Okay. Next thing, after discussing this part, we will move to the second reaction. In the second reaction, for example, you are taking this one, that is CH3I. Okay. This is called as iodomethane. This is, the name is iodomethane, one carbon. All are single bond. So methane, only one substituent group, that is iodine. So iodomethane. So this is reacting in the presence of zinc and copper couple, and that is also in presence of alcohol. So what this zinc and copper couple is doing, it is extracting nascent hydrogen, means hydrogen atoms from this alcohol. So this will be giving you these two things, as a result of which one of this hydrogen will coming and joining this, and one of the hydrogen will be coming and joining this. So you get a product, that is CH4 plus HI. So if you are taking, for example, C2H5I, this is called iodoethane. For that, what product you will get? You are using zinc and copper couple and also alcohol. So what you have to take, you will get is two nascent hydrogen. This two nascent hydrogen, it will break the bond and it will join this two, and this will give you C2H6 plus HI. So you have to understand how the bonds are getting broken and how they are coming and reacting. Though mechanisms are not there in class 10 syllabus, but if you have a general conception that where the bond will break and where they will get incorporated, this concept is very, very important. After that, we move on to the third reaction. The third reaction, okay, don't try to memorize these reactions. Just try to understand the basic framework. So instead of this CH3I, if it is C2H5Cl also, in the presence of alcohol and zinc and copper couple, the reaction will take place in the similar manner, because all you need to find is an alkyl group to which what is attached is a halogen group. That is the general formula that you require, that is R and an X. So this R can be CH3, or it can be C2H5, or it can be C3H7, anything. Or this X can be iodine, bromine, chlorine and so on, anything. Okay, if there is some exception, then that is okay, but otherwise this pattern will be followed. Whenever you will get this Rx, it means I am talking about some alkyl halide. Okay, alkyl means this, halide means this, halogen forming. Okay, halide forming. Okay, now after this we will be talking about a very important reaction, and the name of the reaction is Wurtz reaction. Wurtz reaction, W-U-R-T-Z, Wurtz reaction. Now for this, what you require is to take C2H5Br. For example, you have taken this one. If you have taken this one, plus you have taken 2 sodium. Now you know sodium is highly reactive. So you have to keep it in an organic solvent, which is ether, dry ether. You take 2 molecules of this, 2 moles, this also 2 moles. Now what will happen is, the bond will be broken here. If the bond is broken here, so what do you get? Try to understand. If the bond is broken here, I am showing you this thing. C2H5, okay, Br, and then this is C2H5, that is Br. So what will happen? This C2H5 and C2H5 will join together. If this C2H5 and C2H5 is joining together, the thing that you get is C4H10, that is butane. Okay, and this bromine will join with sodium, this bromine will join with sodium, you get 2NaBr. This is Wurtz reaction. Instead of taking C2H5, you could have taken 1 carbon less. You could have taken it in the form of CH3Br, means bromomethane. Okay, so what would have happened is, this is CH3, this is Br, another CH3, another Br. So this could have broken here. These 2 CH3 would have together joined, and this 2 CH3 would have together joined, and they would have formed C2H6. And similarly, this Br with this sodium, this Br with this sodium, you get this product. So Wood's reaction is a very, very important reaction. But try to understand, if you take 2 moles of methyl bromide, you get ethane. If you increase 1 carbon, you get butane. If you increase the 3rd carbon, okay, you will get hexane. So this reaction is not utilized for manufacture of alkanes with odd number of carbon atoms. But the question is not that. See, we can show you that in chemically or in equation wise, we can form suppose propane or something like that, means alkane with odd number of carbon atoms. But what actually happens, try to understand. Suppose you have taken, instead of taking 2 moles of this, you have taken it like this. 1 mole of CH3Br, okay, plus 1 mole of C2H5Br plus 2Na. Now in the presence of ether, what will happen? This CH3 and this C2H5 will together form C2H5, C3H7 Br, C3H6 H8. Okay, this is C3H8. Now these two if joins together, you get this NaBr. Now try to understand. You are thinking that CH3 plus C2H5 is giving you C3H8. But the thing is not that simple. Because it will break like this. This is what will happen. The bond will break like this. So there are 3 possibilities. This CH3 can join with another CH3 to form C2H6. This C2H5 can join with another C2H5 to form butane, that is C4H10. Or these two can join together to give you this, what you call as the propane. So you will get a mixture of hydrocarbons, mixture of alkane. You will get butane, propane, and you will also get ethane. From that mixture, it is difficult to separate. And that is why Wood's reaction is not utilized for making alkanes with odd number of carbon atoms. This is the basic thing. Chemically it can be done, equation you can write it down, but it is not that simple to solve. So today we learned about these 3 equations. First was decarboxylation reaction, Wood's reaction, and also alcoholic reactions, that not alcoholic reactions, in presence of alcohol, zinc and copper couple, you are utilizing alkyl halide plus those nascent oxygen, this giving you alkane. Now we will discuss about what you call as the chemical reactions. Of the chemical reactions of alkane, today we will be discussing about only one reaction, and that is called this is the dehydrohalogenation reaction. Dehydrohalogenation reaction, try to understand. Dehydrohalogenation reaction. This is not about that. This is about substitution reactions. First, let us understand there is a concept of alkane, and you will get this in the form of this reasoning. Give reason. Why alkanes undergo substitution reaction, but it does not undergo addition reaction. Try to understand this question. Substitution reaction. What is substitution reaction? Means a bond will be broken. One of the part will go away, another part will join there. What is addition reaction? In addition reaction, one of the component will come and just join. Okay. So no one is going, just one is coming and joining there. So what happens? In case of, suppose what you call as alkane, all the bonds of the carbon are satisfied separately. 4 bonds with 4 atoms, it is satisfying. So there is no space left for someone to come and join. Okay, so if we want to suppose chlorine to come and join here, so this hydrogen has to go out. This is substitution. But if it was, just try to imagine, if it was an alkene. If it was an alkene. So you break this bond, you get 2 new bonds. And someone can join and fill these places. For example, this. Is it clear? Have you understood this? So since all the bonds are satisfied with single bond, so there is no space left to add someone, one has to move away. So this is substitution. But here if you break one double bond, okay, the second bond of the double bond, you get 2 single bonds, and there you can add 2 new parts or 2 new components. And that's why alkane doesn't undergo substitution reaction, because no space is left. No bond is free. But alkene or alkynes, they will undergo this addition as well as substitution reaction. Okay. So in substitution, if we discuss, so what happens is, actually, see here, this alkane is present. To this, you actually do add chlorine. You want to add chlorine. So now in the presence of H mu or diffused sunlight, here diffused sunlight is also used. What will happen is, try to understand, one of the hydrogen will be lost. It will, in that place chlorine will come. And that hydrogen will join with another chlorine to form HCl. See, just visualize how this is taking place. Just try to visualize how this is taking place. This chlorine is coming, this hydrogen is going. Okay? So what will happen? HCl. And this is CH3Cl. Is it clear? Is it clear? This is how it looks like after H mu. This is how it actually looks like. Similarly, this is the pattern how it looks like. Now see, similarly if it is CH3Cl, if you add one more chlorine molecule, if it is CH3Cl, if you add one more chlorine molecule, what will happen in place of H mu? One more chlorine will be added, CH2Cl2. This will give you 2 HCl or another HCl. If you add to this one, CH2Cl2, if you add another chlorine molecule, what will happen? To this, actually CHCl3, this is called chloroform, CHCl3 plus HCl. To this CHCl3, if you add another chlorine atom, what will happen? This will give you CCl4, that is carbon tetrachloride, and very important organic solvent. This is what is happening. The substitution is taking place. This is how this substitution is actually taking place. Very important. Okay, so today we are discussing till this much. In the next class, we will be discussing about many other chemical reactions of these alkanes, and then we will proceed to what you call as isomerism as well in the next class. Thank you very much, students. Keep studying, keep learning this chapter as well as other chapters which are being taught in your school. So keep yourself prepared for the exams. Thank you very much. Bye bye.